Upgrading a Daml app means rolling out new versions of its components to change existing workflows or to add new workflows to the Daml app. Upgrades must provide data continuity in the sense that the app state before the upgrade and the workflows that were in flight remain available and continue advancing after the upgrade. In this lesson, we're going to learn the recommended approach to upgrading various components of a Daml app. We will look at the challenges of upgrading Daml apps. Then we will explore the recommended approach to upgrading a Daml app. Then we will learn how to implement backwards compatible upgrades to Daml workflows and what to do when preserving backwards compatibility is not possible. Then we will examine recommendations for testing an upgrade. And finally, we'll learn how to perform a rollback when an upgrade goes wrong. The challenges with upgrading Daml apps stem from the distributed nature of the apps and the fact that they're deployed across organizational boundaries. These challenges include asynchronous rollouts. In most cases, the app users and the app provider cannot upgrade at the same time. Upgrades must be rolled out in an asynchronous fashion and allow app users and the app provider to follow their own schedule for when to deploy an upgraded component. Zero downtime upgrades. Some of the app's workflows may need to be able to progress around the clock. These workflows need to be upgraded with zero downtime, that is, in a way that does not interrupt ongoing workflows. The approach we present provides zero downtime upgrades by default. Mixed version deployments. Because of asynchronous rollouts, the app needs to support some level of mixed version deployments. With the approach that we present, it is sufficient to only provide backwards compatibility of backends and frontends with the DAR workflows from the previously deployed version. In a real-world Daml app, front-ends, backends, and Daml models are likely to evolve at different pace. At any given moment in time, a Daml app is likely to utilize different version numbers for various components of the app. Like a server that implements an API typically evolving faster than the API itself, it's likely that the front ends and back ends will evolve faster than the Daml models and will have a different versioning strategy. The front ends and back ends will then specify the minimum version of the DAR files they require. For simplicity in this lesson, we're going to refer to the version number of all components of a currently deployed and operational Daml app as version 1 and all components of a new version of the app as version 2. The recommended high-level approach for upgrading Daml apps can be described as an asynchronous rollout with a synchronous switchover. Once the app provider has implemented and tested the app components version 2, the app provider makes the version 2 components available to app users. The app provider and the app users asynchronously roll out upgraded backends and frontends and audit upgraded DAR packages. Then the app provider publishes a target upgrade date when they expect app users to have deployed the upgrade and when they expect to decommission version 1. Close to the target upgrade date, the app provider and the app users upload the DAR files in a coordinated fashion so that the new workflows become available on Ledger synchronously as of the target upgrade date. The app front ends and back ends should be implemented to support both version 1 and 2 of the workflows. This allows the app provider and app users to deploy their updates independently on their own schedule. Multiple versions of the components are expected to be in production for a period of time until all app users have deployed version 2 of the components and are ready to switch to version 2 of the workflows. The app provider and each app user first deploy version 2 of the front ends and back ends. And as the last step in the upgrade process, they deploy version 2 of the DAR files on their Canton participant nodes. The version 2 DAR files should be deployed by the app provider and app users shortly before the target upgrade date. This ensures a mostly synchronous switchover to version 2 workflows on the ledger. The uncoordinated switchover to using version 2 workflows can result in workflows getting stuck due to command submission failures when a command is submitted to the ledger using version 2 workflows and the transaction cannot be processed by a participant node hosting a stakeholder in the transaction because it doesn't have version 2 Daml models. Another example, where the command submission will fail due to an uncoordinated switch to version 2 Daml models, is when a version 2 contract is used in explicit disclosure. In this scenario, all stakeholders of the disclosed contract will have uploaded version 2 Daml models to their participant nodes. Otherwise, version 2 contract couldn't be created. But if version 2 Daml models are not available on the participant node submitting a command that includes reference to this contract using explicit disclosure, the command submission will fail. Starting with version 2.9, Daml provides support for making backwards compatible changes to the workflows and their data to handle cross-version interactions with zero downtime. The following backwards compatible changes to Daml models are supported. Newer versions of a DAR package can add optional fields to contract and choice arguments, as well as to choice return types with the following default component behavior. When a component reads Daml values from older versions, the newly added fields are defaulted to none. When a component reads values from newer versions, then the read succeeds if all unknown fields have value none. Otherwise, the read fails as the component is missing an upgrade to deal with the newly set value. This design choice was made to safeguard apps from unexpected data loss. In archive and recreate style code like this one, assuming foo CID points to a contract of type foo with p equal to Alice party, existing field equal to 10, newly added field equal to sum 100. This code would result in a new contract, foo with newly added field equal none being created, instead of the expected foo and newly added field equal to sum 100. As we already mentioned, optional new fields can be added to templates, choice arguments, and choice result types. For the latter, the choice return type must be a Daml record as opposed to scalar types or other assembly types like tuple, list, set, or map. If, when creating a choice, you envisage that sometime in the future you might need to add a piece of data to the return value of the choice, use a Daml record for the return type. It is a good practice to always favor Daml record over tuple as the return type of a choice. The supported backwards compatible changes to Daml models also include addition of new constructors to enums and variant types. Newer versions of a DAR package can add new constructors to enums and variant types. Downgrading a newly added constructor will fail, analogously to how downgrading a newly added optional field that is not none will fail. Newer versions of a DAR package can also add new choices. New choices introduced in version 2 are available on an active contract created with version 1 as soon as the participant nodes hosting the contract stakeholders have all uploaded DAR file version 2. For a choice existing in version 1, version 2 of a DAR package can change the choice controllers and observers. The body of the choice can also be changed, for example to fix bugs or to deal with a newly added choice or contract argument. Choices cannot be removed, but their body can be changed to always call the abort function. The code for computing signatories, observers, and ensure clauses can change with the following limitations. The computed sets of signatories and observers must remain the same for existing contracts. This is checked by recomputing signatories and observers using the code when accessing existing contracts as part of executing a fetch or an exercise. Transactions are aborted if this check fails. The ensure clause is also recomputed and rechecked when fetching or exercising choices on existing contracts. If it evaluates to false, then fetching the contract or exercising a choice on the contract fails. Templates cannot be removed, but new templates can be added. Existing templates that should no longer be used can be rendered inoperable by using the ensure false clause. This will make it impossible to create new contracts using the template. This will also make it impossible to exercise any choices, including the implicit archive choice, on existing contracts created using the template, as ensure clauses are always evaluated using the newest version of the template when the choice is exercised. This strong form of contract immobilization may not always be desired. For example, it may result in a large number of immobilized active contracts stored on the ledger without a way to archive them, unless another update is deployed that makes their ensure clause evaluate to true. Another way to deprecate a template is to remove all references to it from all other Daml code. New interface instances can be added to templates. Interface instances cannot be removed from a template. However, one can make all the interface's choice implementations fail with error no longer implemented. Interface definitions cannot be changed. For this reason, we recommend always putting interface definitions into their own package that only defines the interfaces and contains no templates. To implement ledger reads in version 2 of the backend that are backwards compatible with version 1 of Daml models, transaction and contract filters with symbolic package references of the form of package name, module name, template ID can be used in ledger reads to retrieve data from all contracts that are instances of the template, module name, template ID of any version of package name. Note that it is up to the backend code to handle missing or newly added optional fields. The codegens that are part of the Daml SDK take care of this by implementing the conversion explained earlier, where the value of a missing optional field is set to none. For upgrades, where version 2 front ends and backends use new features such as new fields, variant constructors, choices, or templates, an additional consideration is required. The backends and front ends need to be configurable so that they only start using these new features once the target upgrade date is in the past. Otherwise, a command submission will fail if, for example, it tries to exercise a choice that's not available on all participant nodes verifying the transaction. Not all changes to the workflows of a Daml app fit within the support for backwards compatible Daml upgrades. The approach we've presented for managing the evolution of Daml models follows the spirit of how API evolution is managed in a service-based architecture. For existing APIs, that is the existing Daml code, only backwards compatible changes are allowed. Backwards incompatible changes can be introduced by implementing new APIs, that is, new templates and choices for new workflows. We recommend building backwards incompatible upgrades by introducing new templates and injecting a consuming upgrade choice into the existing templates to archive them and create an instance of the new template. The consuming upgrade choice for the existing templates is added as a backwards compatible upgrade. Where required, reference data for upgrade choices, for example, default values, can be provided via additional choice arguments. Backend automation can be used to actively migrate the old contracts to the new ones. This will incur downtime on workflows until their contracts have been converted by the automation. This approach to upgrading Daml models was discussed in detail in the Course 3 of Daml Contract Developer Certification. Whether an update to Daml models is backwards compatible or not, it is important to avoid package name conflicts, in particular between packages published by different app providers. We recommend adopting the convention from the Java ecosystem to prefix packages with the reverse DNS name of the app provider. For example, for the issuance workflows of the money market fund app provided by Acme Corporation, we'd recommend using a daml.yaml file containing the following configuration: name, Acme Money Market Fund Issuance. Now that we've discussed the implementation of updates to Daml workflows, The next topic we're going to address is testing the upgrades. Testing the type-level compatibility of packages with the same name is easiest done by uploading all release versions and the new versions of the packages to a fresh participant node as part of CI. For this to work, the release star versions used in production need to be available. We recommend managing these in a dedicated artifact repository. Given their smallish size, typically less than 1 megabyte, checking them in with the sources is also an option. Testing the workflow level compatibility is application-specific. We recommend writing at least one integration test that tests the upgrade working for the core workflows along these lines. Start the app using version 2, but only upload DAR version 1. Initialize the app and start one instance of every core workflow. Upload DAR version 2. Switch the flag to tell the backends to start using version 2. Validate that the core workflows are in the same state and advance them to check that they are not stuck. Depending on the complexity of the upgrade, additional, more specific tests might be required. Note that it might sometimes be cheaper to avoid upgrading short-lived workflows and instead just let the in-flight ones complete, and ensure that all new instances are started with the new version. The participant nodes have a feature whereby Daml packages are marked as vetted after they're uploaded and before they're available in production. A participant node publishes package vetting status on the synchronizer so that other participant nodes know in which workflows the parties on the participant can engage. A package cannot be used until it's vetted, which allows to introduce an additional verification step in the process of deploying a Daml package. Note that by default, the packages are automatically vetted when they're uploaded. The packages can also be unvetted. For example, unvetting package version 1 after uploading and vetting version 2 signals that the participant node can no longer engage in version 1 workflows, which completes the upgrade process. If an upgrade needs to be rolled back, for upgrades that don't modify the types of existing templates and choices, this can be done by unvetting version 2 of the DAR package. Upgrades that add new fields to existing templates need to be rolled back in a roll-forward fashion by publishing another upgrade, as long as at least one contract has been created that makes use of a newly added field. The reason is that such contracts cannot be read using the previous version of the Daml code. Just unvetting the new version of the DARs is thus not possible unless it is okay for the contracts that use the new fields to no longer be referenced. Instead, a new version of the DARs needs to be published, which ignores the faultily added new fields. The new version can also add an explicit downgrade choice that resets newly added fields to none so that the contracts can be downgraded to the original version. Backend automation can then go through the ACS and call the downgrade choice. You can avoid the need for these kind of roll-forward rollbacks by breaking an upgrade that introduces new fields into two. First, build an upgrade that only introduces the new fields, but does not use them. Since this upgrade does not do any code changes to choices, it won't have to be rolled back to fix a bug. Second, build an upgrade that changes the choice implementations to make use of the new fields. In case of a problem, this upgrade can be rolled back using unvetting. To summarize, in this lesson we have learned that the recommended approach to upgrading Daml apps is using an asynchronous rollout with a synchronous switchover. Starting from Daml 2.9, Daml provides support for developing and rolling out zero-downtime upgrades to workflows. An upgrade can add new choices, templates and interfaces, change choice implementations, and add new optional fields to templates, interfaces, and choices. Conversion rules are defined for Daml values with newly added fields that make it easy for Ledger API clients to interact with multiple versions of the DAR files. We recommend the app provider to publish a target date for completing the upgrade, uploading the DAR files close to that target date, and having components check that this date is passed before using features introduced in the new version to avoid workflows getting stuck.